This is a test for means, a comparison of two means involving independent large samples. And the problem reads, as you can see, a medical researcher suspects that the pulse rate of smokers is higher than the pulse rate of non-smokers. And we're invited to use the sample statistics below. Use alpha equal 0.05. Okay, the claim. Well, the claim is straightforward and right in front of us here. The researcher claims that the pulse rate of smokers is higher. Okay, this is a mean, so there's what I'm going to write for the pulse rate of smokers. I like to use notation that it reminds me of what I'm working with, is greater than the pulse rate of non-smokers. And that, of course, is the alternate hypothesis. Mu sub s is greater than mu sub n, claim. Null hypothesis then has to be mu smokers is less than or equal to mu non-smokers. The test statistic, let's write it right up here. It's a z. It's x bar smokers minus x bar non-smokers divided by the square root of the standard deviation, or the variance, sorry, of smokers divided by the number of smokers plus the variance of the non-smokers divided by the number of non-smokers. Our numbers are 88 minus 85, square root 4.8 squared divided by 100 plus 5.3 squared divided by 100. And that's equal to what the calculator shows us. Let's see what we get. I'm going to make sure I get a nice picture here. Okay. Paren 88 minus 85 unparen divided by second square root 4.8 squared divided by 100 plus 5.3 squared divided by 100. Unparen, enter, 4.195, about 4.2, okay? Z is equal to 4.2. Okay. And since this is a one-tail test, the critical value is 1.645. That's the rejection region. There's 4.2, and we can see that we definitely reject H naught. Okay. How do we write the answer to our test? Well, we use our helper. Our helper says, first of all, we notice the claim is H sub A, and we rejected H sub 0. Therefore, there is enough evidence to support the claim. So we're going to write that here. There is enough evidence to support the claim that the pulse rate of smokers is higher than that of non-smokers. The pulse rate of smokers is higher. Okay, I got it all in there. Okay, p-value. Okay, in case of p-value, what we're interested in is well, what do we know? Let me tell you what we know. We know that the highest that our z-table goes, this particular z-table goes up to 399. Okay, and that's 4 9s and a 7. So we're looking at the short end of things here. So that will turn out to be less than 0.00003. And that's consistent with rejecting the null hypothesis. Okay, let's try it now. Stat tests. This is a 2-samp z-test. That's 3. The numbers are already in there. Sigma 1 is 4.8. Sigma 2 is 5.3. The pulse rate of the smokers is 88. There are 100 of them. The pulse rate of these other guys is 100 in the sample, and everything looks okay. It is a right tail test. That's what we got here. It's a right tail test. So we select right tail here, and we calculate. And we get pretty much the same thing as what we got, certainly for the test statistic, 4.195. That's 4.2. And our p-value here turns out to be, I'll write it down here in the corner, it turns out to be 0.0000136 versus 0.00003. It is, in fact, less than that number. So we've just done a test for 2 means involving large samples.